Recording in progress.
Hello everyone. In this video we're going to be applying the properties of parallelograms. In most of these examples we're going to be solving for x, but we do have to assume that each of these is a parallelogram before we can actually solve these problems. So let's start with the first one. We're solving for x here. And we're looking at two opposite sides, and just remember that opposite sides are congruent. So that means that these two things are going to be equal to each other. So let's set 18 equal to 3x minus 6. So solving for x here, we're going to first have to add 6 to both sides. So adding 6, this will give us 24 equals 3x. And then solving for x, we're going to divide by 3 on both sides. So that means that x equals 8. That one wasn't so bad. Okay, so let's try out another one. And in this second example, we are looking at consecutive angles. So we know that consecutive angles are supplementary, meaning that they add up to 180 degrees. So in this example, we're going to have to do 66 plus 12x minus 6 equals 180. All right, so just first of all, combining like terms. So we have 66 and negative 6 that we can add together. So 66 minus 6 is going to be 60. So we have 60 plus 12x equals 180. Then solving for x, we need to get the this term by itself. So we need to subtract 60 from both sides. So we're going to get 12x equals 120. And then our very last step to solve for x here is dividing by 12 on both sides. So we are going to get x equals 120 divided by 12 is positive 10. Okay, so let's look at our next example now. This one is going to be finding BD. So let's first mark what we know is true about these parallelograms. So we know that the diagonals are going to bisect each other. That means that this is congruent to this, and this one is congruent to this one. Okay, and we also know that all the sides are congruent, but let's see if we even need to work on any of that. So we are trying to find BD in this example, so we're trying to find this whole line here, and we know that this one is 8, and we know that these two are congruent because diagonals bisect each other. So we know that both of these are 8, which means that the whole line is going to be 8 plus 8, which is 16. So BD equals 8 plus 8, which is 16. Okay, so let's try out number 4. And this one we have to use a little bit of just trying to figure out what things are first. So we know that XV is 24, so we need to find XV, that's this entire thing right here. So XV is 24. And we know that AV is 8 plus x. Okay, so let's say that this is 8 plus x. Okay, now we need to use our properties of parallelograms. So we know that the diagonals bisect each other. That means that this is equal to this. Okay, we know that the whole thing is 24. So we know that one of those halves is going to be equal to half of 24. Or we could say, so there's two different ways we could go about this. We could say that 8 plus x is going to be equal to 12 because that's half of 24. So let's do this one first. Or we could take this alternative route. We could say that this is also 8 plus x. Okay, so we would have 8 plus x plus 8 plus x equals 24. So we could say the whole thing is equal to 24, or we could set this equal to half of that. So solving this way, we'd be subtracting 8 from both sides. We would get x equals 4. And then the other way, 8 plus 8 is 16, x plus x is 2x equals 24. Subtracting 16 from both sides, we would get 2x equals 8. And then dividing by 2, we would get x equals 4. So either way that you solve this problem, you're going to get x equals 4 as your answer. So two different ways of looking at this problem. Both of them are acceptable answers, so just either or in this situation. So this method or this method. Both work. Okay, so let's look at this last problem now, problem number 5. And I forgot to write the instructions for this one, but we are finding J and K. All right, so let's look at this example. We are finding both J and K. So first, let's just find K. So I know that the diagonals bisect each other, so those two things are going to be equal. So let's say set 8K equal to 2K plus 36. Okay, so this is what we're going to be using to solve for K, so let's just go ahead and solve. I'm going to subtract 2x from both sides, or 2K, so we can get the K's on the same side. Okay, so we're going to get 6K equals 36. And then to solve for K, the last step is going to be dividing by 6 on both sides. So we're going to get K equals 6. And now we're going to solve for J. Okay, so let's solve for J now. And we still know that the diagonals are going to bisect each other, so this is congruent to this, which means that we can set them equal to each other. So we're going to have our second set of equations, which is 4J equals 7J minus 12. So I'm going to put the 7 on this side just to make my life a little bit easier. So let's combine our J terms, subtracting 7 from both sides. So we're going to get negative 3J equals negative 12. Then dividing by negative 3 on both sides, we're going to get that J equals 4. Okay, I hope that you guys enjoyed this video, and I hope you have a great rest of your day. Please let me know if you have any questions. I'll be happy to help you out. Goodbye.